You've read the rules, you've created your strategies, you've put in the time, you've done the math. Now it's time to show us what you've got. Welcome to this week's episode of FMA Plus.
Good evening, everyone, and welcome back to another week of FMA Plus. This is week 7 of our shows. Now, as many of you know, with all of our lives online right now, Zoom went down periodically throughout the week. This severely impacted the quality of our recordings. While you'll be hearing our voices tonight, the video didn't quite come through the way we wanted it. So our show's going to look a little bit different today, but we hope you'll bear with us. On tonight's lineup for FMA Plus, we've got Team 834, Spartex from Center Valley, Pennsylvania, Team 6327, the Fighting Gophers from Prospect Park, Pennsylvania, and Team 103, the Cybersonics from Kintnersville, Pennsylvania. Without any further delay, let's take a look at this week's lineup. All right, well, welcome to our show with Team 834, Spartex. I've got Krishna, Ryan, and Kyle, and mentor Mr. Peperato. So why don't you guys introduce yourselves and your team?
Well, I'm Krishna. I'm the president this year.
Hi, I'm Ryan. I'm Pick Communications and a member of the build team.
Hi, I'm Kyle. I'm also on the build team.
Nice. So Krishna, we'll start off with you as our resident president of 834. Maybe you could tell us a little bit about how the Spartex kick off the off season and move through that part of the year.
Well, our off season starts pretty early. We like to attend Ramp Riot almost every year, but then our main goal during the off season is to organize and stock up for the year. So we usually buy parts and get everything ready for the season then. This year, we also did a lot of community outreach. So we went to visit Saucon's FTC team, which was nearby, and we helped them out with a few things. We hosted an hour of code for the middle school. We actually spend an hour there. We give them a presentation about our program, and we also just help them learn using code.org's platform. And then this year, we also helped out the rookie team 8117, which I know you guys have had on the show before, but we helped them out with some team structure ideas and just overall.
Always awesome to see first teams mentoring rookies. And of course, yeah, we did get a visit with 8117 here on the show last week. So let's talk a little bit about your goals. Ryan, what were your season goals this year and why?
So in the off season, we like to set our goals. So we normally plan short-term and long-term goals regarding competitions and such. What our short-term goals were, we wanted to win at least one of our district events, whether that be Chestnut Hill or Seneca. If we get past that stage, we wanted to attend World Championship in Detroit and possibly get picked by a team there or be one of the Alliance captains.
That sounds like some solid goals, definitely well-defined, and the right balance of challenge as well as attainability, which is a good indicator of, well-developed priorities. Speaking of priorities, Kyle, maybe you could talk a little bit about how 834 prioritized the different challenges in this year's game.
All right, so this year, right after kickoff, we started looking at what gave us the most points in the game and prioritized mostly based on that. We're starting with climbing, as that gave us the most points. We also want to be able to pick up, store, and shoot balls quickly, while also being able to store 5 at a time since it's the limit. And we wanted to hopefully be able to shoot balls from the far range, and hopefully with an adjustable hood so we can aim up and down.
Very cool. So let's start diving into that robot design.
Okay, so in the beginning, as Kyle said, we all get together and brainstorm what we want to do. So we had a Saturday meeting and decided, all right, let's just sit down and figure out what would we want to do as design mechanically. So we were debating the size of that robot, whether that be tall or short, the different types of intakes, climbers, and drivetrains. What we ended up choosing was we wanted a tall robot for a better release point and design, an intake that has vector wheels for centering, and a ball transport system with a storage for the 5 balls.
Okay, cool. So yeah, you guys wanted a tall robot. You're looking for a maximum of 5 balls on board to maximize your cycle value. and you talked a little bit about the intake style. So what did you end up coming up with? What was the final product of this year's robot?
Well, after looking through all of our choices, we put together the final thing, and we call it BB834.
So let's take a walk through. I love the name. Let's take a walk through BB834.
All right, so our drivetrain, it's a custom parallel plate 8-wheel drive chassis powered by 6 Neo motors, and it's driving using 6-inch Coulson wheels on 5.33 to 1 reduction. The design of it's based off of our 2017 and 18 robots, with only a minor redesign to be able to cross the 1.1/8-inch height barrier.
Yeah, so I'm a big fan of using the Coulson wheels on the drive base, and given this year's terrain, it sounds like a really good choice. And obviously, the 6-inch diameter is perfect for that barrier at the rendezvous point. Ryan, can you tell us a little bit about the intake?
All right, so for the power cell intake, we decided on a full width over bumper style, which was outfitted with the vectored wheels, which I mentioned earlier from Team 125. The wheels allows us to index or center the balls from the start, which we won't have to do manually then. And then these wheels are all 3D printed from PLA material on our own team's Ultimaker and a Mentor's printer.
Very cool. I love seeing the use of 3D printing sort of make this a revolution in FRC. Kyle, what about the ball storage for the robot?
So for our storage, we chose to use a ball tube design, and it has a toothed belt on one side to move the balls up and down. And the balls are spaced. We've spaced the balls properly with a photoelectric sensor. We had one issue though making it, that there was a dead zone between the intake and tube, so the ball would go into the intake, but then not make it all the way to the belt and just kind of spin there. And we fixed it by putting a plywood wheel in between them to keep the flow.
That's awesome. Super creative solution to a potential issue. Sounds like you guys got up and running pretty quickly too, which is good. Krishna, tell us a little bit about the 834 shooter.
Well, our shooter, it went through a lot of changes over the season. We started off like everybody was all for the 2-wheel shooter. It was giving us like great results, and we were building it. We made multiple prototypes and it was working. But then a little bit later into the season, some students went back and made a single wheel shooter design just to test it. And we found that it was much better overall with more accuracy and further distance. So we ended up using a 1-to-1 shooter with Neos, running at 4,500 RPM. And the shooter was made of 2 5-inch Coulson wheels with a polycarbonate hood.
This is what our old shooter prototype looked like with the original double wheel design. And this is what our new shooter prototype looked like with the new single wheel design.
Nice. I always love hearing about the iteration that teams go through their design process. So Kyle, let's talk a little bit about Endgame. What does 834's climber look like?
So our climber this year was made out of 2x1 80/20 with a similar style to that of our elevators from previous games. It uses a lead screw driven by a versaplanetary to move up and down. And since there was a height limit this year, we used a torsion spring to flip the hook out for extra height. And along with our old goal of trying to be able to climb from almost anywhere, our hook is double-sided so that we can go on easily from either side of the bar. And it worked pretty well this year from our testing. An original goal was to have it be able to slide along the bar to help balance out, but we couldn't get that running in time.
That's a well-developed climber approach. It seems tried and true. Definitely very practical. Krishna, can we talk a little bit about the programming side of things on 834 now?
Well, programming is always the fun part for us. So this year we used command-based programming in Java. We also took advantage of the built-in PID loops on the Spark Max motor controllers to get the shooter wheel up to speed. We were able to test the 3-ball auton, and it worked, but since the season was cut short, we weren't really able to get further than that auton-wise. So this year, our vision was very different than most teams. We actually had a student put in a lot of work, and our vision system is based off of a neural network that we actually trained from scratch. All the teams came together to label over 2,000 images, and with the help of Always AI, the company, we were able to put a Raspberry Pi with a neural compute stick on board and just run an AI vision system on there. And it actually worked out really well. After a few weeks of testing, we were able to get it to recognize all the balls and goals with over 90% confidence.
Wow, that's awesome. Definitely a very unique aspect to the vision challenge, at least in our region, in FMA. I don't know of any other teams currently that are using a neural network that they've trained from scratch. They might be out there, but I have not heard from them yet. So, congratulations, you guys. That's a huge asset to have, and a huge skill set that your team now has, which I think will be helpful in years to come. So, even though you haven't had a chance to compete just yet, I think the neural network is going to earn its keep in the 834 tool belt for sure. Is there anything else about Team 834 that we should be made aware of as we start to wind down here?
So we want to thank our school, all of our sponsors, coaches, and mentors who've helped us throughout this season and to get us to where we are today as a team.
So if I want to learn more about Team 834 Spartex, where can I find you guys?
Well, you can always find us at team834.org, and we want to thank you for watching our section of FMA Plus.
Of course, we appreciate you being on the show. Thanks so much.
All right, so we're here with Team 6327, the Fighting Gophers. I'm here with student representatives Jimmy, Nate, and Francis, and we're also accompanied by their mentor, Mr. Dave. So with that, I will hand it off to you guys. Let's learn a little bit more about the Fighting Gophers.
Hello, we are the Fighting Gophers. We are a 6-member community team, and 3 of us are here tonight. I'm Nate. I started on an FLL team and immediately joined FRC. I've been in the team for 4 years now. I've been the driver for 3, and this is my first year as the team captain.
I'm Francis. I've been around for 6 years. I've been on the team for 3. I joined through our summer camp program, and I'm the operator.
I'm Jimmy. I've been around for 4 years, and I have been on the team for over a year. I joined through the FLL program, and I operate most of the computer-aided machines, and I am also an electronics specialist.
Very nice. Now, when I see your team number, I seem to remember the Tin Soldiers or the Tin Men. Obviously, this year, the name is the Fighting Gophers. So I'd love to hear a little bit about your rebrand.
Yeah, so the whole thing started because we wanted to further separate ourselves from our mentor team. We wanted to build our identity and step out of their shadow. We got the name from one of our events last year. At that event, one of our mentors had an animatronic gopher from Caddyshack in their truck. It managed to infiltrate the pits and make its way to the driver's station. We immediately took it as a good luck charm and danced with it at the beginning of each match. We ended up winning that event and getting the teams its first blue banner. This name change also got the tin out of our name, once and for all putting an end to the Wizard of Oz jokes. Even though we have separated from the Tin Mints, we are still one family. We help each other through the hardships and make it in the end.
Nice. Yeah, I think it's cool that you guys, recognize and have gratitude towards your mentor team or your the team that helped you guys get off the ground. But it's always healthy to have your own identity and kind of bring yourselves to the table in the way that you want to, which is awesome. I also love the origin behind the Fighting Gophers with the Caddyshack gopher animatronic. So that's awesome. So let's talk a little bit about the beginning of the season. From what I understand, you guys have a little bit of a unique kickoff experience. Maybe we could talk a little bit about that.
So, yeah, we got to go up to New Hampshire to see the kickoff live and see the field up close. We got to meet some pretty cool people from First Headquarters like Dean Kamen and others. Once we got back to our hotel, we drew our robot designs on giant Post-it notes. We had strategic meetings to plan out our robot and our strategy. And on the way home, we had special breakout groups in the car rides to optimize our 8-hour car drive home to its fullest.
I love the idea of a road trip strategy session. That's really smart. So, go on this road trip, go on an awesome kick. I love the live kickoffs. I think they're really fun. A chance to see the field up close is invaluable, especially in recent years with the field being so wild. So after kickoff, you guys got home. What did you decide on as your team strategy and why?
So we decided there were a couple key points that we really wanted to hit with our robot this year. We wanted to make sure that our robot was different from 4575's robot, because if we had the same robot as them, we would just kind of be reversing some of the progress we had made with making an identity for ourselves. And we wanted to really keep the robot simple this year to lower the maintenance of it, so we would have more time to strategize from match to match with our alliance members. And we wanted to really focus on doing one job well rather than trying to do everything and not being that great at it. And we decided that the best way to do that was to be a small and compact robot that went through the trench.
Cool. Yeah, I think those are some great priorities to have. Both strategically and also from a branding perspective. I think it's smart that you guys considered that detail when you were looking at the direction to go in with your final robot design. Were there any other reasons that you guys decided to go with a small or maybe a short robot versus a tall robot?
Yeah, so the whole reason we went with a small robot is so that we could use the trench and control panel to its fullest. We wanted to kind of use it as a highway where we would pick up balls from the feeder station and cycle them to other teammates that would shoot the balls into the goal, so that we could have a constant cycle of picking up balls, dropping them off, where they wouldn't have to go back and run around, where they could just sit in one place and shoot and gain as many points as possible. We also want it to be small so that we can hide in the trench almost and shoot from there and have a lot more protective shooting instead of having to deal with defense.
Yeah, that makes a lot of sense. It's a smart thought about how you're going to cycle on the field as you go to make those design decisions. So Francis, let's start from the design process as getting into building the robot. What was your prototyping process like?
So as soon as we got back to the shop from our planning session on the road, we really just wanted to get as many different prototypes as we could so we could start comparing them against each other, because we had this long list of ideas from that 8 hours. One of the things we were really focusing on with our prototyping, though, was the shooter. The rest of it, we did prototype a lot with it, but not as much. And with the shooter, we didn't know if we wanted to go with one wheel or two wheels, if we wanted to go with a lob shot or a straight shot. And we eventually had to realize that the ceiling was a bit too short, and so we kept hitting it, and we left a couple marks up there that the people weren't too happy about.
Yeah, absolutely. That's a a classic story from robotics teams past is the damaged drop ceiling, and maybe I don't know what happened to the drywall. It's crazy. Somebody must have broke in and thrown a ball at the wall really hard or something.
Yeah, so weird.
Let's talk final design now. So where did you guys end up with your final shooter approach?
Yeah, so we decided that two wheels left and right would be our final design instead of the one on the bottom and pressing up against another surface. We were hoping that the two wheels, since it's more of a direct shot, we were hoping for it to be more accurate than the lob shot of the other design. Our shooter is also at a fixed angle. It's not able to adjust at all. And we were hoping that we could just have one spot on the field where we could sit and we wouldn't have to deal with changing the placement of the shooter each and every time we wanted to shoot. The problem that we did find was that when we were shooting the balls, it kept ripping apart. But we found out these maroon compliant wheels that we had were able to grip the balls just as well. It was just as accurate, but it wasn't ripping them to shreds.
Now, in most of the robot walkthroughs we've done with teams, we tend to go from the ground up. With you guys, we're kind of going from the shooter backwards. So winding our way backwards through the robot, how did you guys get the power cells into the shooter?
So we used our advancer. It was extremely simple, and we got it built within the first 2 days. And the part we really liked about it was that it was reliable. We used Darwin rollers, and we made extra parts so we could switch between different types of belting to see which one was the best. And we used Darwin rollers and belts and a piece of polycarbonate on top to compress the balls to take them from the intake to the shooter.
Yeah, so I think the advancer being reliable like that is clutch, right? Reliability is everything, and so is consistency. Which it sounds like you guys have an interesting approach to this design, where you're thinking about the attributes to your strategy while you're also trying to design the aspects of the robot, versus just coming up with a way to pick up a ball and pass it to a shooter and shoot it, and then figuring out how to play with that. You guys are thinking about how to formulate your robot around a strategy that you want to achieve, which is, I think, a really healthy approach. So let's talk about the intake. Francis, maybe you can tell me a little bit about how you guys are actually acquiring the game pieces.
Yeah, so we followed that same strategy first idea with this, and we really wanted to have the intake go over the bumper somehow. so that we could be strong as possible with our frame not having a giant cut in it, so that we could play defense if we needed to, or if people were actually playing defense on us. And so we started off by using the recycled arms from our sister team's Stronghold robot, because we actually liked how they would actually reach over the bumper, and the kind of shape of them worked well for that. And so they were a bit too heavy, so we made them into metal sheet cutout of that. And we started off by just having a bunch of wheels on that, but that was a bit too heavy. So it switched to the same belts that our Advancer had.
Very nice. What was your guys' plan for Endgame?
So we had the unique idea of a scissor lift. We wanted one on each side so we could climb better on the rail. We used recycled rails from the Pepsi factory. We liked the worm drive aspect of the threaded rod, as the robot would stay up once the motors were turned off. We started as a chain and sprocket, but that did not work, as the chain would pop off as soon as the robot tried to lift. We changed to a direct drive, but that still struggled and the motor would still stall. We reevaluated using the lift and the design we had already put in so many hours into. We started working on how to use the lift and for hook drop-off, and using a separate winch motor to actually lift the robot. We were working on this final change when everything got shut down.
So one of the biggest problems that we were running into was the weight of our robot. With the scissor lift taking up most of that weight, we were trying to get as much weight off of the robot from everywhere else to try and spare it for the scissor lift to be on the robot. And so the intake had to go through multiple different versions just to try and get that weight down as low as we could. And we were switching aluminum to polycarb left and right wherever we could spare it without getting too weak in some areas. But eventually we just had to realize that the scissor lift was a bit too heavy to be practical, so it had to be switched to something else.
Even with the mechanical problems, our electronics team was still able to continue working due to the fact that our electronics was able to be removed and worked on. We've been working on this electronics box over the past couple years, trying to design it as tight and compact as possible. We wanted to be able to kind of put it in our robot and not have to really think about it and have to deal with it being in the way of other functions of our robot. We designed it to be easily removed, so during competitions, we can fix something quickly and put it back in between matches and not have a problem of taking too long. We built it side by side with our mentor team, 4575. So if we're both at a competition and either of us have a problem, they can lend one of the electronics box to us or to them to continue working during the competition.
I think that's a really clever use of components, right? When you know something's going to be serviced all the time or most of the time in the pit, might as well make it really easy to work with. Did you guys have any other challenges this season you guys want to talk about?
Yeah, so in early January, we had a lot of team members out sick with the series of colds and the flu throughout the season. When you only have 6 team members, having 3 out sick for a meeting puts you way behind schedule.
Yeah.
And if that wasn't enough, in February, we tried to move our entire shop. We had to move every single machine that we had, and just like some of the machines were a lot of work. Just the lathe itself took almost an entire day to move from one shop to the other. And while we were trying to move, we were still trying to run FLL and FLL Junior. And that didn't go too well because we tried to do it in just a weekend, but it wound up taking a week and a half, which wasn't that great. But we were lucky to have some help from 4575 and the Prospect Park Fire Company, which really helped speed things up, even though it still did take a while. We just really underestimated how much time it would take to pack up everything and unpack it.
And just when we got settled and were back working in our shop, the COVID shutdown happened. So we attempted as quickly as possible to switch everything online, like our FLL and FLL Junior programs. Even our FOC meetings have been moved to Zoom.
Yeah, I mean, it sounds like you guys have had your fair share of challenges this season, you know, even before going to competition and competing with your robot. That being said, now that the season ended, what have you done to keep your teams together?
Yeah, so even with everything going on, we still wanted to continue our younger programs. We have them meet once a week on Zoom, and we explain different things such as gear ratios and how to improve upon their robot. We also work in code.org to continue their programming skills. We make sure to always have someone online to help people through any issues with trying to get a link up or trying to get into the Zoom meeting. We do plan to continue helping our community with different activities. Currently, we're working on a Science in a Box concept where we deliver science experiments to doorsteps and work with different experiments with kids via Zoom. And we're looking into hosting virtual birthday parties.
That sounds like a whole heck of a lot of fun. I definitely want to come to the science experiment, the science fair on Zoom. So tell us a little bit more about some of the outreach you guys do each year.
We enjoy going to maker fairs. We do small ones at local high schools and large ones at UPenn. Innovation fairs or breakfasts up at the Convention Center in Oaks, and other fairs, including Comic-Con for kids as well as demonstrating at PAC East. A lot of times we bring out this scrubber droid. Jimmy, do you want to talk about that?
Sure. So we have a scrubber bot. It's modeled after a Star Wars droid scrubber bot. It's small so it can fit in the back of a car. The little robot has 4 omnidirectional wheels so it can drive on all directions. And it also doesn't scratch floors, which is very important. You don't want to leave scratches all over someone's floor. And we use it in our current shop, the mall, as constant outreach. It's made of recycled parts, and it gives people a look into what FRC is like because it uses FRC electronics and coding.
The bot was really helpful at the events that we went to, such as Robot Stock. There, the Tin Mints gave us a section to work on that we called Maker Row. There was tables set up where makers could show what they work on and what their hobbies and interests are. There was a table there that we had set up that we called Take Apart. There was old electronics there that people would take apart and reverse engineer and figure out how they work. Everyone had safety glasses and screwdrivers to figure out how to take them apart.
That's awesome. I think I would have, as a little kid, I would have been a huge fan of the take apart table, and I would not have known what to do if you asked me to put it back together. more than likely.
Same. I'm so excited to get back to competitions just so I can hang out with the Fighting Gophers. I know exactly what pit I'm going to be hanging out in for the rest of the season. So if we want to learn more about Team 6327, now the Fighting Gophers, where can we learn more or contact you guys?
You can find us at Instagram, Facebook, or on our website. I would also like to take this time to give a shout out to our sponsors, EPRA, Headshot Props, Boeing, DoD STEM, Intuitive, L3 Harris, and Comcast NBC Universal.
All right, well, that's going to do it for tonight with 6327, the Fighting Gophers. Thank you to Jimmy, Francis, and Nate, and their mentor, Mr. Dave. You guys were awesome to talk to tonight. Really interested to hear about how the team has progressed and grown. Really excited to see what groundskeepers you're going to torment in the future.
All right, we're here with Team 103 Cybersonics. I've got Mackenzie, Colt, and Eric, as well as mentor Carlos. So why don't you guys tell me a little bit about one of our Hall of Fame first Mid-Atlantic teams?
Absolutely. So we have been a Hall of Fame team since 2003. We have been building robots for 25 years now, and this is our 23rd year with First.
That's very cool. Now, one of the things that we discussed before we started, filming for tonight, is you guys have a couple of really interesting ways of both fundraising and getting involved with the community. So, Mackenzie, why don't you tell me a little bit about those, starting with Basket Bingo?
So our Basket Bingo is held in October, and it's personally one of my favorite fundraising events. This year, we raised a record amount in the past 5 years. And we also rearranged the cafeteria in our school to make it more efficient for raising money. This year, we also sold some of the coffee that we now have. We partnered with 4 Monkey Coffee, and they made up a very creative logo for us and are helping us with branding.
Very cool. So, Mackenzie, it looks like you are the resident expert on all of our fundraising and outreach. So let's move right down the line to the spaghetti dinner. Tell us a little bit about that.
Sure. Spaghetti dinner is held at our local firehouse in Regalsville. It's normally in December, and here it's an all-you-can-eat buffet with Alfredo sauce and all sorts of different type of pasta. And normally for this fundraiser, we have gift card wreaths. Each student donates a gift card, and then we raffle off. I think this year we had 3. We also started to sell terrariums as a team bonding opportunity. The students got together and we built terrariums and sold them at this fundraiser.
That's awesome. I love seeing the different ways that teams both engage with the people around them and, of course, you know, bump their budget for the year. But speaking of sort of media and marketing and business, let's talk about how you guys got into your season this year. Mackenzie, let's get us started.
Okay, so I am the only senior on the media marketing department, and this year we decided to take up the challenge of new team apparel and spirit gear. So we created a variety of options for our students this year. We have several quarter zips to pick from. We also have team water bottles this year. And we decided to spend a little bit of our money and get a banner for competitions. That way our parents can easily spot us and our fans can support us. And then we also decided one of the biggest challenges that we had as far as the media marketing department was what to do with our showcase. It's in our school hallway, and before it held all of the awards we won, and it was never cleaned and not very appealing to our fellow students. So we decided to split the showcase in the middle, one side for manufacturing, one side for media marketing, and display more of our team bonding and what we've achieved in the years.
Nice. Yeah, I think it's cool that you guys, you know, you were afforded a cool space to show the team off to the public by your school, and you guys decided to revamp it and take some pride in it. I also see that you guys have some game pieces and some old robot bumpers. That's awesome. Probably some great conversation pieces for sure. So Eric, we've learned a little bit about the outreach and the fundraising efforts of 103, which is a huge foundation for a Hall of Fame team like the Cybersonics to be built off of. Let's move a little bit further into the technical realm now. Can you tell us a little bit about the manufacturing aspects of build season?
For sure. So manufacturing our robot, we go to the kickoff. This year we went to the one that was hosted by Cougar Robotics. And then right after kickoff, everyone goes home. Everyone gets to print their own manual. Everyone gets to spend that night reading, going through, coming up with like a little mental strategy, thinking about what they want to do. And then we come back to school the very next day. And one thing we do that's a little different than a lot of the teams is the students kick the mentors out into a different room. So that way they can talk what they want to talk about and we get to talk what we want to talk about. And we find that kind of like it doesn't allow the mentors to taint our minds and like really influence our decisions. So that way they can come back and see what we came up with. And then after we do all of our discussions on what we want to focus on and what we decide to go with, we start prototyping. And at our school, we have a full machine shop, which is actually really super useful for FIRST Robotics. It allows us to create a lot of interesting prototypes, a lot of interesting robots. And this year, our prototyping was very in-depth. For me as a senior, it was the most prototyping I actually saw throughout my 4 years. I mean, it was really cool to see how we chose this thing and then we would modify it as we went through the design process, and then how we would rule out certain designs, or we would implement this design into this design and kind of make like a mishmash.
It's always really neat to learn about teams' prototyping processes, and I especially love the idea of like kicking the people with too many perspectives from previous seasons out of the room and letting you guys fly. That's definitely interesting. What about the build process, right? So you do your prototyping, you figure out what you want to do. What about that actual manufacturing process?
So over the past recent years, we've really increased the amount of student involvement. So for me, the past couple years being an upperclassman, so last year and this year, I've really had the opportunity to teach the underclassmen what I've learned, and it allows for a lot more student participation. So if you ever come in our shop, you'll see a lot of the students doing a majority of the work, and then a lot of what they learned was taught to them by an upperclassman who had the same opportunities and who learned it from a mentor previous years far back. And then we get to teach them the problem solving and the machining skills that they'll need to teach the underclassmen eventually when they become an upperclassman. And then you also have the mentors who volunteer their time to come in, and they get to give their perspective, teach you their super valuable knowledge that they've gained in their industry. And it's just a really fun process.
Yeah, that's cool. I appreciate the attention to trying to cultivate the next generation of cybersonic team members, right? So you, as upperclassmen, you guys recognize the responsibility you have to make sure that the underclassmen are brought up, which keeps the team thriving and successful and competitive for years to come, which is great. So Colt, can you tell us a little bit about the building of the game field itself?
Yeah, of course. So every year we get our parents come together. So the parents of the students actually get to get involved a little bit in this one. So just sitting on the sidelines. And our field is built by parents and volunteers. And it's really awesome. We build a mostly fully functional field, except for like a couple of the fancy lights and stuff, but everything works. And we build one every year. And the parents get to come in, they build it. It's a really awesome opportunity. And my dad personally has done it and came in and helped. And he said it really gave him a deeper appreciation for what we do as a team.
Yeah, I know that in the early days of my team, we didn't have a practice space, and we're not that close to 103, and we hauled all the way out to that field to make sure that we could practice, and it changed the way that we do our build season. So the fact that you guys have that field and make it available is just awesome. Now, there's something in here I gotta ask about. I just see vacuum sealing. Can you elaborate on what that's about?
Yeah. So teams over in Asia and whatnot, and Israel and all those teams, getting power cells out to them was very costly, because as already here in the US, they were really hard to get your hands on, and over there, they were also super expensive and at really absurd prices. So we decided to help relieve that a little bit and take a little bit of the pressure off. So we got quite a few power cells. So we ended up vacuum sealing quite a few of them so we could ship them out to teams over in Israel, Asia, or whatever, and help them so they didn't have to spend as much money looking for them.
That is awesome. Super creative solution for a problem in terms of shipping, right? I imagine most of the high cost of shipping power cells doesn't come from their weight, right? It comes from their volume. So you guys, reducing them down into little pancakes must make it much more cost effective. And I'm sure the teams overseas were super appreciative. I'm sure you guys really helped them out. So kudos to you guys. So let's talk about programming, Colt. Maybe you can walk us through some of the software challenges and situations that 103 went through this year.
Yeah, of course. So I am one of the lead programmers for our team, and I recently took that over. This will be my second year on the team. I'm a sophomore, and I am the oldest person on the team that's programming, so I've been there the longest. And in past years, we haven't had a programming mentor at all. I mean, Carlos would jump in and help where he could, which was always nice. But we didn't have like a designated mentor to help with programming. And this year we actually got a programming mentor, which was awesome. His name is Jeremy, and he really came in and helped out the team a lot. But he was a former FRC participant, so he's an alumni. And it's been quite a few years since he was in FRC, so a lot of things has changed. So catching him up on everything and also teaching all the new programmers was a big challenge that we overcame, as well as doing vision, because usually in the past couple of years we had vision like back in 2017, then we didn't really use it all that much because I didn't really know what was going on, and slowly figuring that out and implementing it into a robot was really awesome.
All right, well, thank you for letting us in a little bit more to your season, to your process, and to your space. Mackenzie, Eric, and Colt, as well as mentor Carlos, we so appreciate your time tonight. If I want to learn more about Team 103 Cybersonics, where can I find you online?
So last year, our freshman created a new website all by himself. So we take pride in that. And he's now a sophomore, and he has moved on to our business plan graphics. But you can find us at cybersonics.net. And our website has information about our past robots and our team history, as well as our student and mentor board, and also how to reach out and help us fundraise or helping with building the field as well.
Awesome. Thank you guys so much. We appreciate your time. That's it for our lineup this evening on FMA Plus. We appreciate you coming to hang out with us live here on First Mid-Atlantic's channel. Next week, we've got a really special show for you. Given the news that Infinite Recharge is coming back for 2021, we figured it would be a great time to dive in on strategy and on-field gameplay. So we're going to have a fully live coaches panel next week right here on YouTube. We're bringing in some awesome coaches. We've got Bob Dudek from 365, Chris Gregory from 1089, Michael Leicht from 1403, and Nathan Canals from 2729. We'll jump into match play from week 1's Hapro event and talk strategy, taking questions and comments from the chat as always. A huge thank you to our entire FMA Plus crew for making this happen. We couldn't have done it without the whole group screening, interviewing, and editing down these team features, as well as moderating chat, coordinating social media, and keeping you all informed. We'll see you next Saturday for another awesome episode of FMA Plus. Everyone have a great night.